The final topic in this lesson is called horizontal scaling, sometimes referred to as sharding. Now, sharding refers to partitioning the data from one single big table in a database across multiple independent databases based on a sharding or partitioning key. So it's like partitioning across multiple different databases. So the example we've got here, we've got a customer table is partitioned across multiple independent databases based on customer ID. Each independent database will store data for one or more customers. Now, sharding and horizontal scaling, it can be very helpful when the data is too big to fit in one single database. The data is to be distributed to different locations. So perhaps for improved performance or for compliance. For example, European customers will get improved performance if their data sits in a European data center rather than an Asian data center. We might want to isolate tenants or customers to a database of their own for better management and performance. If all of the customer's data is in a single database and there is blocking, for example, in the database because of a certain transaction made for a customer, let's call it customer X, then all other customer queries will have to wait for that blocking to be resolved, which can lead to poor performance and a poor experience for the rest of the customers. It might be a single database that requires a premium service tier to manage one big table, and then dividing customers' data across multiple independent standard service tier database can reduce costs. So we have one database in our sharding lineup that's on the premium tier, and the rest of those databases or shards are on the standard tier. It can also be helpful when all or most of the queries made to the database filter on the sharding key. Now, sharding is supported natively in Azure SQL database, so we don't have to implement a sharding mechanism from scratch. However, we do need to create and manage shards. These are the databases. Okay, and creating and managing these shards can be easily done using the Elastic database tools. Now, sharding is supported natively in Azure SQL database. We don't have to implement the sharding mechanism from scratch. However, we do need to create and manage the shards or the databases, and this can be easily done using Elastic database tools. Now, the diagram we have here is a generic sharded environment. The customer table is horizontally partitioned across 3 shards, so shard 1, shard 2, and shard 3. Each of these being an independent database in their own right. Now, let's look at each of these components in a little bit of detail. Now, a shard is an individual database that stores a subset of rows of the sharded table. So a shard is an individual database that stores a subset of rows of the sharded table. Shard 1, 2, and 3 are shards, each storing different rows of the customer table as defined by the mapping. Now, a shard set is a group of these shards or database that contain the data for a single partition table called a shard set. Shard 1, shard 2, and shard 3 together are called the shard set. Now, we need to understand the concept of a shard key. A sharding key is the column name based on which the data is partitioned between the different databases. Okay, now in our example, customer ID is the sharding key. Each shard stores data for a different customer ID, and you can define a composite sharding key if you want to. The Shard Map Manager is a special database that stores a global mapping information about all available shards in our shard set. The application then uses the mapping information to connect to the shard based on the sharding key. Shard maps will define the data distribution between the different shards or databases based on the sharding key. There are 2 types of shard map: a list shard map and a range shard map. A list shard map is a key value pair with a one-to-one mapping between a sharding key and the shard database. The key is the sharding key and the value is the shard or the SQL database. The list shard map defines shard 1 will store data for customer ID 1, okay, and customer ID 4. Shard 2 will store the data for customer ID 2, and shard 3 will store the data for customer ID 3. Now, range shard maps, this is a key value pair where the key or the sharding key is the range of values defined as sort of the low value and high value. The range shard map defines that shard 1 will store data for customer IDs from 1 to 100, okay, and also customers from 300 to 400. Shard 2 will store data for customers with customer IDs between 100 and 200, and shard 3 will store data for customers with a customer ID between 200 and 300. Okay, this brings us on to global shard maps, or GSMs. Global shard maps are stored in the Shard Map Manager database and record all the shard maps globally. This information is stored and managed by special tables and stored procedures created automatically under the _shard management schema in the Shard Map Manager database. Now, local shard maps, or LSMs, are referred to as shardlets, and these are the shard maps that track the local shard data within individual shards or databases. The local shard map or the shardlets are stored in individual shards and not in the Shard Map Manager database. The information is stored and managed by special tables and stored procedures that are created automatically, again using the _shard management schema. Reference tables are tables that aren't sharded and are available in all shards. These can also be stored in another database, say a reference database, instead of storing the same data in individual shards. For example, a table with a list of countries or cities which has got master data common to all shards. Now, the application cache, applications accessing the Shard Map Manager cache the mappings in a local in-memory application cache. Applications use the cache mappings to route requests to correct shards instead of accessing the Shard Map Manager for every request.